the cortex, then this screw is required. These are also cancellous screws with only part threaded. These are called partially threaded cancellous screws. This, in contrast, is a fully threaded cancellous screw. The partly threaded cancellous screw is useful as a lag screw. So the next question is, what is a lag screw? A lag screw is a screw that fixes two pieces of bone by its own inherent structure. This part fixes this piece and this part fixes this piece. When the screw is advanced like so, this part is driven along with the head onto this part, and once the screw is very tight, these two parts are held tightly together. That is the use of this partially threaded screw. If you look at the end, you will see that it is finely tapered. Instead of this, if you have a head that is tapered like so, it is called a self-cutting. And if it is a flute that is a cut on the side, that is called a self-tapping. So, in contrast to this screw is a self-cutting, self-tapping screw. That is, if you want to insert the screw, theoretically you need to neither drill the bone nor tap the bone. However, if you are inserting a cancellous screw which looks like this, you have to first drill the bone, then tap the bone, and then only you can insert the screw. So now we know the difference between the cancellous screws which are kept here. These are also cancellous screws of a smaller variety, and these are basically cortical screws. Now, one thing that may produce confusion in the exam is this. This is not a screw which is used for the bone. This is the main screw for a DHS or a DCS. This is the DHS screw, and this is the plate part of the DHS. Once these are inserted, they are held together tightly by this screw, and this is the screw, and it prevents this from coming out. So this is not a screw which is used for bone. It is part of a DHS or a DCS. Okay. On first appearance, these plates may look alike, but after you look at them carefully, you will notice a significant difference. What is that? First thing, even though they have a plate and a barrel, the angulation is totally different. This is angled at 135 degrees and this is angled at 95 degrees. So, from this you understand these are two different types of plates. This is called a DHS, that is a dynamic hip screw, and this is called a DCS, that is a dynamic condylar screw. The DHS is used to fix trochanteric fractures. The method by which it is fixed is like this. First, the screw is passed into the neck after reducing the fracture, and then the barrel is slid onto the screw and the plate is fixed onto the bone. If you superimpose this plate over a bone, it will look like this, and this is the classical DHS fixation. The final result will look somewhat like this. The DHS plate is outside and the screw is inside. This part is fixed with the locking screw or the locking nut. This is the dynamic condylar screw. The dynamic condylar screw is classically used in supracondylar fractures and also in supracondylar, intercondylar fractures. The mechanism is different for each. If it is a supracondylar, intercondylar fracture, the intercondylar element is first fixed using the screw, and then the supracondylar element is joined to the main screw by means of the plate. In a successful fixation, the final result will look somewhat like this. It is fixed onto the lateral side of the bone. In a supracondylar fracture, this part is fixed to this part by the plate. However, if it is an intercondylar supracondylar fracture, it is also called a T or Y fracture, and the easier terminology is called T-Y fracture. Remember that even though this is called dynamic, the only true dynamism is there in this DHS. The DHS is in the true sense a dynamic screw. Why should a DHS be dynamic? The DHS, the main screw, goes into the neck. As you all know, the neck angle will become smaller and smaller. That is, the neck will go gradually into a varus as the age increases. Over and above that, the fracture will slowly collapse as it heals. When this happens, the screw of the dynamic hip screw slowly moves inward into the barrel like so, and allows for a collapse of the head. That is, when the head moves downward like this, the screw moves inward into the barrel. So this is in the true sense a dynamic screw. However, when you come to the condylar screw, this is not dynamic. Even though you call it dynamic, the only compression you afford is when you lock the barrel onto the screw using the main locking screw. After that, you cannot give further compression. There is, however, an alternative to this, that is this. This is called the 95-degree blade plate. Once the fracture has been reduced, this is driven into the condyle in a manner which is very similar to the DHS, and the final result from outside will look very much like this. The blade has an introducer to make way for the plate, the blade, and finally the plate is screwed to the side of the bone. Now, all these plates look similar, but are they? Just like the screws, the plates also have different varieties. The basic types of plates are shown here. If you look carefully, almost each of them has a shape which is different from its predecessor. And this is the classical plate that we all use. This is called the dynamic compression plate. This is another of them, and this is another. If you want to understand the difference between a dynamic compression plate and an ordinary plate, all you have to do is to look at the screw holes. A dynamic compression plate has got a peculiar type of shape for the screw holes, like this. But you compare it with the screw holes on a DHS and you will see the difference. Now, let us see what is the difference. The screw hole on a DHS is perfectly circular. That is, a screw that is inserted into the DHS will simply go to the center and rest there. However, if you insert the same screw into a DHS, it comes to rest at a different part. Even if you insert it distal, it will come to rest towards the proximal side, that is, towards the middle. That is the peculiarity of the dynamic compression plate. It provides compression together with the fracture fixation. Let us see how this works. When you have got two fracture fragments and you want to fix them using a DCP, this is what is happening. This is the middle part of the DHS and it should come onto the fracture site. When the screw is fixed to the DHS, you saw that the screw moves downwards but also towards the middle. This screw hole and this screw hole are mirror images. The screw in this screw hole goes towards this side. The screw in this screw hole also moves towards this side. So, when the screw moves down, it also pulls this fracture fragment to this side and this pulls this fracture fragment to this side. Finally, when the dynamic compression plate has been fixed onto the bone, there is, in addition to fixation of the bone, a compression at the fracture site and you get a final force of around 100 kilopascals at the fracture site, which helps to accelerate the healing. Now, even though this is called as a dynamic compression plate, the preferable name for this should be an auto compression plate. Now, what is the difference between DCP and an ordinary plate? Earlier, the ordinary plate had a hole which looks just like this. What they used to do was they fixed the plate to this fragment, put the screws, then reduce the fracture, and with a compression device they pulled this fragment onto this fragment and reduced and also gave the compression, and then they gave the screws on this area. Once the DCP had come into vogue, the necessary of giving a compression here using a compression device was later lost. That is, the insertion of the screw itself gave compression for the dynamic compression plate, and therefore this was called dynamic. But in reality, the only thing that it does, it gives a single compression at the time of fixation and not afterwards. Therefore, the ideal name should be ACP, but however, this instrument is called DCP. Just like the K-nail and the external fixator, the DCP is another of the implants that has helped to revolutionize orthopedics. A DCP comes in many sizes. This is the standard 3.5 system and this is the 4.5 system. Sometimes you need to fix a large number of screws to make the fracture stable. In such case, if you keep the holes close together, it will be like perforating a paper and you can tear the paper along a dotted line. Similarly, the bone will fracture along the line of screw holes. Therefore, if you want to put a larger number of holes, use this. This is called the broad DCP or the staggered DCP. This DCP has got holes in a single line, whereas this DCP has got holes in two lines. This helps to eliminate stress along a single line, and you can put a larger number of holes with a smaller length of the plate. After the DCP, another instrument that can lead to confusion is this. This is called the 1/3 tubular plate. Even though it looks similar to a DCP in size, you can see that the 1/3 tubular plate has got circular holes. These holes seem elliptical because they have been drilled onto a tube. How is this a tube? If you look at it carefully, you can see that it has got a almost semicircular cross section. This is actually theoretically 1/3 of a tube. The 1/3 tubular plate, if you view from the back, you can see the difference. You can see that the holes in the 1/3 tubular plate are circular, whereas there are elliptical compression holes for the DCP. Also, The DCP